Hello everybody. Today we are going to solve puzzle number 19498. This puzzle is of difficulty 10 and you can notice that the number of trials is about 1000 while only successful trials were 300. Now I'll start the puzzle. Note that this is 1, 2, 3. Here we have 8, 9, and the remaining are 4, 5, 6, 7. This leads us to exclude the 9 and 8 from the 12 because it must include 4, 5, 6, or 7. Note that here we have a sum of 15 of 5 cells, which has the only possibility of 1, 2, 3, 4, 5, where the 3 cannot be in the 6 here. Now, after excluding the 8 and 9 from here, note that the 8 and 9 cannot reside here. So both of them are here in this cage. And so the 10 cannot be 1, 9 or 2, 8. Also note that the 8 and 9 here will exclude the 8 and 9 from here, also from here, and they cannot be in the 8 or in the 6. So both of them are in these two cells. So here we have 8, 9. Now let's move to the to this sequence. Now this is less than this. This is less than this, and now here we have a maximum sum of 16 because it cannot be 17 while here we have 8 and 9. So the maximum here is 16. Also note that the maximum here, the minimum here is 11, which is 8, 1, 2. So let's get the maximum of this cage. Now we have 16, 16, 15, and here we have 14. So the maximum for these two cells is 6. So now we have 1, 2, 3, 4, 5. The maximum for this sum is 6 with an 8 here. Now also I'll move to this is interesting because note that here we don't have 1, 2, excuse me, here we don't have 9, 8, but also here we don't have 9, 8. So the 9 and 8 must be in these 5 cells. But could the 7 be there? If the 7 is here, so here we have 4, 1. But the 4, 1 will contradict with the 6 here. So this cannot be a 7. So the 7 is not here, it's not here, and is not here. Also the 8 and 9 are both not in any of these cells. This is interesting because the 7, 9, and 8 would be in these two cages. But now let's discuss the possibilities here. They cannot be all in the same cage because this would add to 24, and it cannot be equal to this. So one of them is in one side, and the third is and the two others are in the other side. So suppose here we have 7 and 8, which is the minimum possible value if two of the three are here. So if this is 7 and 8, this must be 16 because the sum here is 15. So this must be 16 or greater, but it's also less than 16. So the result is that this would be 16 and this would be 16, which is 7, 9. On the other hand, if 7 and 8 are here, then the minimum value for this cage would be 178, which makes also a 16, and it cannot be greater than 16 because this is limited by 16. So what I am saying is that in both cases, either the 7 and 8 are here or they are here. In both cases, here we would have 7 and 9. And I think this is the main thing about the puzzle, because this conclusion will lead us to have great progress later on. And this is I think this discovery is the reason why there is a great number of attempts with failure. Now the 7, 9 here would make this an 8, and would make the 7 and 9 here. This would be a 6, and the 8 here would make this a 9, and here we would have the 8 in one of these two cells. Also, we note that the 10 is either 3, 7 or 4, 6. So this is 3, 4, and this is 6, 7. Now we have something less than 10, but it cannot be 2, 3, 4. So it must include a 1. So this is not a 1. And it cannot include a 7 also, because the 7 plus 1, 2 would be 10. It may include a 6, that's possible, but also it must include either 2 or 3, because if it does not include 2 or 3, the minimum for it would be 1, 4, 5, which is 10. So here we have a 1 with 2 or 3. Now, this would lead us to this 22 here. Note that the 22 cannot be 4, 5, 6, 7, because in this case, if it's 4, 5, 6, 7, then the 8 and 9 would be here, which will be contradictory with the 8 or 9 here. So it's not 4, 5, 6, 7. Thus, it would include 1, 2, or 3, but none of them may reside here, because one of them is here and two of them are in the other edge. So the 1, 2, and 3 cannot be there, so they must be up there. Now I'll move back to to this box here. Note that the box, the sum here is 34, so the remaining cells would add to 11. This cannot be. Note that the maximum value for this cage, if this is 16, 16, 15, 14, this is 13. So maximum. So this cannot be 8. It cannot be 7 because of the 7 here. It cannot be 6 because of the 6 here. It's 5, 4, 3, 2, and it cannot be 1 because the sum of these two cells is 11. But note that the 2 would make this a 9, which contradicts with the 9 here, and the 3 would make this an 8, which contradicts with the 8 here. So this is 4, 5, and this is 6, 7. Also, note that if this is 5, 6, then this would be 1, 7. The conclusion here is that in this box, either we have a 7 here, or it would be there. The 7 is either here or here. So it cannot be there. It cannot be in this column. It cannot be there. So the only remaining places for it are these two places. Here with a 3 or here with an 8. Now, also note that if this is 1, 5, then this would be 2, 6. If this is 1, 5, then this would be 2, 6. Then the 2 cannot be there. And if it's 2, 4, the 2 also cannot be there. So this is not a 2, and this cell cannot be 7 or 2. Also, we can discover what this can be. Suppose this is 1, 5, then as I said, this is 2, 6, and this would be a 7, where this cannot be a 7. So the 7 is here with a 3. And this cannot be a 3. What is the conclusion here? The conclusion is that in this case, the 3 cannot be anywhere in this column, which is contradictory. So the conclusion is that this is not 1, 5, it's 2, 4. And this would be 1, 3, 5, and the 1 cannot be there. Let me repair this. Now, as I said, here we have 1 with 2 or 3. But what if the 2 is here? If the 2 is here, then we would have here 2 and 8. So the 7 is not here. The 7 would be there. And with this would be minimum 1, 4, 5, which is contradictory with being less than 10. So the 2 is not here. I'll repeat. If the 2 is here, then the 7 is here, and here we would have a 3. Then this would be 1, 4, 5 minimum, which is contradictory. Now, if the 3 is here, then we would have 3 and 8. Then this is 4, 6, and the 7 will have no place in this box because it's either here or here. We've eliminated it from here by supposing that this is 3, 8, and the 3 here would eliminate the 7 from being in the 10 here. So here we cannot have 2 or 3. Note also that because the 2 is not here, it must be there because it's also not in this column here. So it's either here or here, and here we would have a 3. So this is 1 2 and this is 1 2. Also this would eliminate the 3 from here, and here we would have 1 with 2 with either 4, 5 or 6. Also, you'd note that eliminating the 3 from here, and it cannot be in the 6, and it's not there, so the only remaining place for it is in the 12. And this would lead us to have a 3 it cannot be with a 6. It's either with 4 5 or 7 2. And here we don't have a 3. Note that the 7 2 will make this a 1, and we would have 1 2 3, which contradicts with the 7. So it cannot be a 7, and this is not a 2. The 4 5 here with the 1 2 here with the 1 2 4 5 here would force this to be 6 or 7. And also note that the 6 and 7 cannot be there, so the other place for them is here. So we have 6 or 7 here and 6 or 7 here. And this would be an 8. Now, this cannot be 1 2 6, so it's either 1 2 4 or 1 2 5. I'll write it this way. This is 1 2 4, or if it's 1 2 4, then this is a 3 7, and this is a 5. And if it is 1 2 5, because the 1 and 5 cannot be there. If it's 1 2 5, then the 4 would be there, and this would be a 3. That's great, because the 3 and 5 here prevent the 8 here from being 3 5, and it's not 2 6 because of the 6 here, so it's 1 7. So here we have a 6, here we have a 5. So this is a 5, and here we have 2 1. So here we have a 3 4 6. Now note that here we have 28 plus 3 31, so the sum here is 14, which does not have include a 6, so it's 5 9. The 5 9 would make this an 8 9, and the 5 here would make this 2 4 5 1 2 1 4, and here also here we have 4 6 5, so this is a 6, this is a 7, this is a 4, and here we have 6 7 8. The 1 and 3 here makes this 2 5 in this order, and the remaining cells for this column would be 6 8 with 7 and 9. But note that the 7 and 9 are reserved here, so this would be 6 and 8, which makes this a 7, and this would be a 9 7 The 7 here forces the 7 to be there, and it must be with an 8, because the 8 and 9 cannot be both in this in this cage. So this is 7 8, and here we would have okay, let's get that. Here we have 6 8. This cannot be 4 or 5 because they are here. And now we can get this cell. This is 16 plus 11. That's 27. So we need 18. This is 15. So this is a 3. The 3 cannot be with a 5 or 4 here, because, and not with a 3, because this must be less than 15. So now we have 1 6 9. So this is a 5 and this is a 9. Okay, the remaining cells here are 2 and 3. Note that this is 2 8. So this is 2 and this is an 8. So this is 7 8, and here we have a 3 with 4 9. The 6 cannot be there because of the 6 here. Now the remaining cells here are 1 3 5 9. This 15 does not include an 8. It cannot be 2 6 7 because this is 1 3 5 or 9. It cannot include 3 and 5 together. It cannot be 4 5 6 because note that the 4 and 6 and the 5 prevent any one of them to be in this cell. So could it be 159? Note that if it is 159, then the two remaining cells here would be 3, which is not possible. The 159 will exclude the 1 5 and 9 from here, and the remaining possibility here would be a 3. So it's not 159, so it is 2 4 9. 4 2, and the 9 is not here. Also the 1 is not here. Here we have 1 6 9 6 9, but the 4 here would make this a 9, and the 9 here would make this a 6, and here we have 1 7. This is not a 5 because of this, and this is a 5. Here we have 1 6 7 8. Note that here we have 1 2 3 4 5 6 7 8 9. So this is a 5, and this is 6 7 8. This is not a 1 because of the 1 here. This is not a 6, and this is not an 8. Also note that the 4 in this row, the 4 is not here. It's not here because of the 4 here, so this is a 4. Now if this is 4 5 with suppose this is 6 or 7, then the minimum for this cage would be 16, because 5 plus 4 plus 6 would be 15, plus 1 So this is 16 minimum, this would be 17, and this would be 18, which is contradictory. So this cannot be 6 or 7, it must be a 1. And this is 7, 1, 7. So this is 8, 6, 9. Here we would have this is 1, 1, 3. Here we have the remaining cells are 1, 2, 3. So this is 1, 3. This is 1, 3. So this is 2. The 1 cannot be there because of the 1 here. So this is a 3. 1, 3, 5, 3, 5. Now, here we have 1, 9. And here we have 2, 6. This is 7, 8. Note that if this is a 9, then the minimum value for it would be 9 plus 6 plus 2. So this would be 17, which cannot be less than this cage. So this is a 1, 9. The 9 would make this 7, 8. Excuse me, this is not 6 or 8, it's 7 or 8. And this would be 8, 7. The 2 here would make this 4, 2. Now here we have 1 and 5. So this is 3, 5. Finally we have 3 and 4. So 2, 4, 6, 2, 8, 6. So that's it. The most difficult part of the puzzle was, I think, to discover that this must be 16 after noticing that the 7, 8, and 9 are must be or must reside in these two cages, and that the minimum value of a cage containing two of them would be would force this to be 16. Thank you for listening. Meet in another puzzle. Goodbye.